Okay, first of all, I want to say good job to you guys because you did awesome on your online quizzes last week. We had a couple people that needed a little bit of extra help, but as a whole, we did pretty dang awesome. Most of the class got all greens on their quizzes, and I think that's really cool. If you didn't, please make sure you email me and we'll get you caught up and we'll get a retake for you. I'm not even doing true retakes at this point. I'm just having you guys do corrections to get credit back. So make sure you get in touch with me if you didn't get a green, but as a whole, you guys all did pretty well in the quiz last week, which is awesome. So this week, we are going to mostly focus on section 8.1.4, and that's factoring completely. So if you want to have some extra practice problems, I would go ahead and pull those from 8.1.4. Also, if you're kind of questioning some of the stuff what we're going through, 8.1.4 is going to give you a little bit more detail than just what we're doing in the video, because if I did the whole lesson for you guys, it would probably take me an hour to get through it, and I'm sure you don't want to sit through an hour video. So I'm pulling the main pieces and giving you guys some examples, and that's what we're going to do together. Okay, to start, I want us to do a little bit of a warm-up problem. This is review from the stuff last week. So I'm going to have you guys pause right here, and when you restart this video, it's going to have the solution on there for you to check your answer. Please make sure you're doing this on your own first, though. You're going to get a lot more out of it if you pause it and do it on your own, and then check your answer than you will if you just see my answer. So go ahead and pause your video. Okay, here is my answer. I kind of tried to color code this for you guys so that you could see it. Obviously, the first thing I did was rewrite this in our standard notation. So we don't have just an m term there. Make sure you write it out in standard notation. So we have 81m squared plus 0m minus 1. So if I have a missing term, that means I have 0 of that term. So we have 0 m's. The next thing I did was go ahead and make my box, and I filled in my 81m squared and my negative 1, so my first term and last term. Then I made my diamond problem, and remember we get this negative 81m squared by multiplying our first and our last term. My 0m is just my middle term. And then I found out that negative 9m times negative 9m is negative 81m, and negative 9m plus 9m is 0m. So I went ahead and put those in my box, and then I found my factors. I found that in this first column, my greatest common factor was a 1, so I pulled out a 1, and I found out in this second column that my greatest common factor was a 9m, so I pulled out a 9m and I wrote down my new factors. So then in this top row, I'm left with a negative 1, and in the bottom row, I'm left with 9m. And that gives me my factors of 9m minus 1 and 9m plus 1. Later on, you guys are going to learn about something that's going to give us a shortcut when we have a problem that's like this, that has your squared term and your last term, and both of them happen to be perfect squares. But we're not there yet, but keep it in mind that I'm going to show you a shortcut for just this particular case later on. Okay, this whole section is about making sure we are factoring completely. So I am going to give you our definition for factoring completely, and then we're going to discuss what that actually means. Okay, so a polynomial is factored completely if none of the resulting factors can be factored further using coefficients. So we're going to make a column of factored completely and not factored completely. Remember that if I write it down, you should probably be writing it down as well. Okay, so I'm going to give us an example. If I have x plus 3 and x plus 4. That is factored completely because I can't take anything out of either of those. However, I'll give you an example of not factored completely so you can see the difference. If I have 2x plus 6 and x plus 4, this is not factored completely. And here's the reason why. This first part, I can take a 2 out of 2x and a 2 out of 6. So if I take a 2 out, I'm left with x plus 3. Because if I were to distribute this, I would get 2x plus 6. So then I would still have my x plus 4 at the end. Now it would be factored completely. Another example of a factored completely, why don't we just write that one down? 2x plus 3 and x plus 4. If I have 3x and x plus 1, that is factored completely. If I have, let's see, 4x squared, actually let's do x to the 4th, plus 2x, this is not something that's factored completely. We can take some common stuff out of all of this. I can take an x out of both of those, and I can take a 2 out. If I have 2x, I need to multiply by another 2x to get 4x to the 4th. And if I have 2x, I need to multiply by a 1 to get 2x again. That would be factored completely. So 2x and 2x plus 1. These are all factored completely. These ones are not factored completely, so these ones are the only ones that are not factored completely. Okay, so let's do an example that we're going to have to use this concept for. So if I have this polynomial, it's actually a quadratic, I'm going to factor it first. And there's two possible factors that I could get for this, so I'm going to go ahead and do this with you guys so that we all have the same one that we're working off of, and then we'll simplify it further. So I'm going to start by drawing my box. And I have my first term and my last term. Then I have my diamond. And the top of my diamond is these multiplied by each other. So I'm going to have negative 12x squared. And then my middle term goes in the bottom of the diamond. So negative 3x. And we need to see what factors will multiply to negative 12x squared, but add to negative 3x. Whoops, I accidentally wrote this problem down wrong. And here's how I know I did, because I listed out my factors over here, and none of these would multiply to negative 12x squared and add to negative 3x. I meant to write down negative 4x. So go ahead and change that on your guys' also. Negative 4x. That'll help you out a little bit. So with that being said, now I'm going to have 2x and negative 6x. So negative 6x times 2x is negative 12x. Negative 6x plus 2x is negative 4x. And I'm just going to put it in my box. So negative 2x, sorry. And that's positive also. And this is negative 6x. Now I just need to pull out my greatest common factors. So in my first column I can pull out a 2, and I'd be left with x here and left with 3 here. I can pull out a negative 2x in this column. I'd be left with an x here, and I'd be left with a 3 here. Then I'm just left with 3 and x. So I would get negative 2x plus 2 and x plus 3. Now this is the part where they're talking about factoring completely. So if I go back, it says a polynomial is factored completely if none of the resulting factors can be factored further. I think there's a greatest common factor in one of these factors, and that's this first factor. I can take a 2 out of here. 2 times negative x is negative 2x. 2 times 1 is 2. And then I will be left with x plus 3. So I just took out my greatest common factor in that first factor. Now there's nothing else that I can take out of there. That is the simplest version. Okay, this is problem 36 out of section 8.1.4. And this talks about how we can tell if that's going to happen, how we can tell if we're going to have a factor that we can pull something more out of. And I'm going to give you guys the little trick to figure out if you can. So from the beginning, for example, if I start with negative 3n squared plus 9n plus 6, when I start out, before I do any factoring, if I can take something out of each of those terms first before I start factoring, then it has a greatest common factor we can take out from the beginning, and we would be able to do that at the end as well. So I could actually take a 3 out of all of these. So I'd have 3 times n squared is 3n squared, plus 3 times 3 is 9, and then we have an n, and then 3 times 2 is 6. So I could take that out from the beginning. So now it says, without factoring, predict which quadratic expressions below may have more than one factored form. So we're just going to find which ones we can take something out from the beginning. So I could take out a 2 on here and have 6t squared minus 5t plus 1. On 3, I could take out a 5 and have 2x squared plus 5x minus 3. This one I could not take a common factor out of, and this one I also couldn't take a common factor out of. There's nothing that I could pull out of all of those. Now if you guys get something that looks like x cubed plus x squared plus x, or something like that, that's a really good clue. See how this is cubed? We don't know how to factor anything that's cubed yet, so that's a good clue. You're going to take an x out of each of those, and we'd have x times x squared is x cubed, plus x times x is x squared, plus 1 is our final answer. And then we could factor this part. Okay, now we're going to do problem 38 in the book. We're going to do one together, and then I'll have you guys do one. Then we'll do one together, and I'll have you guys do one. And that will be the end of our lesson. So let's start out with 3x cubed minus 6x squared minus 45x. So this is what I was talking about, how it's cubed. We don't know how to factor cubes yet. So we're going to have to pull something out from the beginning to even be able to try to factor this. But there is a number that we can take out of all of these as well. We can take a 3 out of all of these. So 3 times 1 is 3. We can also, before I write this down, we have to take an x out of each of these. Each of these terms has an x in it, so we're going to go ahead and just take the x out. So we can take a 3 out and an x. 3x times x squared is 3x squared minus 3x times 2x is negative 6x squared, and then minus 3x times 15 is negative 45x. So you should be able to distribute these back out and get your original answer. That's a good way to check yourself on all of these and make sure you have the right thing from the beginning. Now, we are going to ignore that 3x until we are at the very end. So we're just trying to factor this. we're not trying to solve it. So I'm going to write 3x down here because we're going to ignore that until the very end, and I'm going to scratch it out up here. So now we just have a quadratic, which we know how to factor. So let's go ahead and just factor this quadratic. I have my first term in my first box, my last term in my last box. I'm going to draw my diamond. Remember, I do these two multiplied for the top, so negative 15 x squared. My middle term goes on the bottom. And I'm going to list my factors of 15 to see which one I'm going to use. So I have 1 and 15. 2 doesn't work, but 3 and 5 does. So I'm going to have negative 5x and 3x. So negative 5x plus 3x is negative 2x. Negative 5x times 3x is negative 15x squared. So negative 5x and 3x. I can take out a negative 5, and I'm left with x and 3. I can take out an x, and I'm left with x and 3, and then I'm just left with x and 3. So usually we would just say our factors are x minus 5, x plus 3. However, we had a 3x left from the beginning, so up here we had a 3x. So we're just going to use that 3x and put our other factors on there. And that is the whole answer. So we took out our greatest common factor. So greatest common factor, and then we just factored like usual. We just had to make sure that we put that 3x back in there right at the end. Okay, I want you guys to try this one. It's factoring negative 5 or positive 5x squared plus 15x minus 20. So go ahead and pause this, and when you click to press play, it's going to have my answer with my work. Please make sure you're pausing it because you're going to get a lot more out of this video if you do. Okay, this is my answer, and you can see that I pulled out a 5 from the beginning. 5 was my greatest common factor, and I went ahead and just wrote it straight at the bottom. So that's my green 5. It's what I pulled out from the very beginning. Then I just factored it like usual, and I got these two factors, and I put them with the 5 at the end. So this is the same thing that we've been doing. We're just pulling something out from the beginning as well. Okay, we're going to try this one together now, and this is also a really good clue that you're going to have to pull out a greatest common factor from the beginning so that we can factor completely, because we don't know how to factor this if not. This is going to be really tricky for us. So there is something that we have in all of these. I have a y in all of these. So I'm going to pull out the y first. So I have y, then I'm left with x squared minus 3x minus 10. And we can do that. That's easily doable. So let's go ahead and do that problem. Oops. Okay, so I have my box, I have my first term, my last term, then I'm going to do my diamond, and I'm going to have negative 10x squared, negative 3x. If you don't know which ones to do right away, make sure you list your factors of 10. So we have 1 and 10, 2 and 5, and we can see that we're going to have a negative 5x and a 2x. So 2x minus 5x is negative 3x. 2x times negative 5x is negative 10x squared. So I have negative 5x and 2x. Let's see what we can pull out now. So I can pull out a negative 5, and I'd be left with x here and 2 here. Then I can pull out an x, and I'd be left with x here and 2 here. So then I'm just left with 2 and x. So we have x plus 2, x minus 5, and then remember we have our y up here. So we need to bring it back down, and we have a y on the outside. That would be my final answer. So my greatest common factor just goes right back in at the end on the outside. Okay, now I'm going to have you guys try this one on your own. This is actually one of your problems that is on your homework. It's probably one of the harder ones on your homework. So I figured we would just go through it together. So I want you to pause the video, try this one on your own. If you don't get it or you get stuck, go ahead and press play again and see where you got stuck and find where your mistake is. If not, go ahead and go through the whole problem and then press play to check your answer. Whoops, I did forget something on here for you guys. This is a 3, not a 2, sorry. So go ahead and pause this and then try it. Okay, this is my final answer. The trickiest part of this, you guys, is honestly finding the factors of 252. So if you look, I listed mine out, and I just listed them until I found one that worked. So 36 minus 7 is 29, and 36 times 7 is 252. The rest of it's pretty straightforward. I pulled out a k squared from the beginning, and I made sure I put my k squared back in the end. The rest is all the same as everything we've been doing. So go ahead and do your homework. The big thing, you guys, is you have quizzes again this week, just like last week. You just have one quiz this week, though. And it's shorter than it was last week by far. But I'm not going to have a whole lot of sympathy if you don't do well on the quiz, because the homework, I put the answers on there too. So you should be doing your homework and checking your answers, and if there's some that you're not getting from the homework after you check your answer, please email me and ask me for help, because that's your chance to get help before you do that quiz. I have those answers there specifically for that reason, so that you guys can do a problem and check your answer, and then if you didn't get it right, try to see if you can find the error, and then if you can't, ask me for help, and then do the next problem and check your answer. So please make sure you're doing that before you do your quiz. You guys did pretty awesome on your quiz last week though, so I'm not super worried about you. Just keep on the same track and let me know if you need any help.